Okay, so next we'll discuss what is supercomputing. Now, supercomputing or a supercomputer refers to a computer which leads all other computers when it comes to processing speed and memory. A supercomputer is nothing but a computer which has immense speed and processing speed and memory when compared to other computers, and it is able to achieve this through something known as massive parallel architecture. Massive parallel architecture. Okay. Now, if you take your normal system, okay, your normal computer. Now what happens? Whenever a task is being performed, it is performed in a linear or a serial manner, one after the other. So one task is performed, after that the next task is performed. So at a time only one task is performed. But if you take a supercomputer, several tasks are performed at a time parallelly. Therefore, greater the processing speed, greater the memory. Hence, you are able to achieve more in less time. Supercomputing is all about speed, memory, and time. Follow? Understanding what I'm trying to say? Yes, see, in your computers, you have something known as RAM, random access memory. Okay, so 2 GB, 4 GB, 8 GB. More the RAM, more will be the processing ability of your system. Why? The memory of the computer to fine, better this way. I give you mathematical calculations to do. For example, 10 into 20, 20 into 30, 30 into 40, 40, plus something into minus something. Now, you don't have to remember everything forever. But while doing that calculation, you'll have to remember everything. So who is able to give me the answer the fastest? Whoever is able to calculate, whoever is able to do mathematical operations quickly and is able to remember one operation to another operation numerically, answers. I'm just giving you a crude example so that you're able to understand what I'm trying to tell you. Yes or no? So greater that memory, you will be able to do it much quickly. Plus, it has something known as massive parallel architecture, where instead of doing one task after the other, multiple tasks are, processed or taken up simultaneously for greater speed. Now, the thing is that supercomputers, see, you don't need a supercomputer to make a PPT presentation. You don't need a supercomputer to type a Word document, correct? Supercomputers are actually used for performing mathematical operations. Not a simple mathematical operations. We are talking about forecasting weather, the calculation, meteorological, or simulating the explosion of a nuclear weapon, simulation of disasters, very fast data analysis. So I'm talking about large, complex mathematical operations. Okay, where it is difficult for humans to do these operations very quickly. That is where we need supercomputers to do large scale mathematical operations very, very quickly. Now the problem is that in a computer, computers work on binary digits, correct? It reads everything in the form of 1 and 0. It reads everything 1 and 0. So even if I write the letter, number 2, that number 2 also is read by the computer in the form of whatever. I don't know what is the ASCII for it. I'm just telling you. Okay, there's some ASCII for 2. I'm just giving you an example. 2 may be represented in like this. 3 may be represented like this. Now the thing is that imagine I have very large calculations. Okay, something again divided by. Now this is not complex mathematical operation that supercomputing is used for, but I'm just for the sake of, so that you're able to appreciate. So imagine writing everything in terms of ones and zeros. So a computer will need more memory and more processing speed. That is why we make use of a supercomputer. And hence, when it comes to a supercomputer, we measure the processing speed of a supercomputer in flops. Unlike your normal computers or your other computers, whose processing ability is measured in the form of MIPS, million instructions per second. Normal computers processing speed or other computers processing speed is measured in terms of MIPS, million instructions per second. How many instructions can it perform? How many instructions can it perform per second? But when it comes to a supercomputer, its operating speed capacity is measured in flops, that is floating point operations per second. Floating point operations per second. So two things I want you to remember when it comes to supercomputing. One, it makes use of something known as massive parallel architecture. What is it? Nothing but taking up multiple tasks parallelly, and its processing speed or ability is measured in terms of flops, floating point operations per second. Why is it floating point operations? Because floating point refers to the decimal points that might be involved in numerical calculations. Okay, so here now we have something known as the National Supercomputing Mission. So the National Supercomputing Mission is by the Department of Science and Technology and the Department of Electronics and Information Technology, which will be implemented through central institutes like IISc, Indian Institute of Science. So now both grid computing and supercomputing are used for processing speed. So what is the difference between a supercomputing and a supercomputing and grid computing? The only difference, both are same things. What did I tell you in grid computing? There's a task, the task is subdivided in multiple subtasks and they are taken up in different primary systems or across the grid. So here also we are doing the same thing. We are taking a task, each task is conducted simultaneously. It is processed or analyzed or whatever it is, the computing takes place parallelly. The only difference between grid computing and supercomputing is that grid computing is also supercomputing, but the difference is that in grid computing, the primary system, sorry, the secondary systems, for example, or the various systems that are present in the grid may be located far away. Meaning one computer may be in Bangalore, the other may be in Chennai, the other may be in Bangalore. They are all connected through a network. Whereas in a supercomputer, there is no multiple systems which are connected through a network. Rather, all the processors are present in one single system. Is this clear? Understood? In supercomputer, all the processors are present in one single system. So processing takes place at one particular location. Whereas in grid computing, there are several computers connected via a network, hence forming a grid. Therefore, processing takes place over a large area across several systems which are connected via a network. So understood the difference between grid computing and supercomputing. So the National Supercomputing Mission wants to achieve supercomputing, but achieve supercomputing through grid computing. So what it will do is that under National Supercomputing Mission, through DST and DAT, several high-performing computers across India are going to be connected via a network to come out with a supercomputer. It is nothing but grid computing itself. But grid computing is also used for supercomputing. Hence, under National Supercomputing Mission, we don't have one single one single supercomputer which could match up to several of the supercomputers across the world. If you take China, China has the largest number of supercomputers. The fastest supercomputer is by IBM Summit. It is, or I think it's around 200 petaflops, if I am correct. Petaflops, 10 power 15 floating point operations per second. Mega is 10 power 6, Giga is 10 power 9, Tera is 10 power 12, Peta is 10 power 15. So we're talking about 10 power 15 floating point operations per second. Okay, so we don't have one single system, rather we are connecting several high performing computers or systems across India to come out with a supercomputing machine. Mostly it will be used for various weather forecasting, for example. It might also be used for solving social problems, where under National Supercomputing Mission we have come out with a supercomputer known as Param Shivai. We are calling it as Param Shivai. Okay, so Param Shivai supercomputer is 833 teraflops. Teraflops. See, it is not more than 200 petaflops. This is 210 power 15 flops. This is 833 into 10 power 12 flops. Okay, where Param Shivai will be used for solving social problems. It could be traffic management, it could be irrigation, monitoring of irrigation schemes across India. So it is mainly meant for solving social problems. Okay, so now we have two high performance computers, HPC, two high performance computers by the names Pratyush and Mihir. Pratyush and Mihir. Okay, so Pratyush is 4 petaflops and Mihir is 2.8 petaflops. Pratyush is in IIT Mumbai. Mihir is with National Center for Medium Range and Weather. So when you add Pratyush and Mihir, you get a total of 6.8 petaflops. So now Pratyush and Mihir with a total capacity of 6.8 petaflops will be basically used for weather forecasting. Okay, it could be cyclones, whatever it is, basically for weather forecasting. And this combination of Pratyush and Mihir coming out to 6.8 flops pushes India to the 4th position in terms of supercomputing speed, restricted only for weather forecasting. I am not telling you in supercomputing we are at the 4th spot. We are not the 4th fastest. We are the 4th fastest in supercomputing when it comes to weather forecasting. That is, when we add Pratyush and Mihir together, we get 6.8 petaflops together. Okay, so this is Mihir.